Good morning. In today's class, I will give you some problems based on magnetic force. These problems are to be solved using the Lorentz force, or I can say that in other words, when it is only the presence of magnetic field, the force acting on a moving charge is given by F is QVB sin theta. Take down the first problem. Use the expression F is equal to F is equal to Q into V cross B. V cross B to define the SI unit of magnetic field. To define the SI unit of magnetic field. SI unit of magnetic field. Use the expression F is Q into V cross B to define the SI unit of magnetic field. Now here given F is Q into V cross B. Given F is Q into V cross B, and we know the magnitude of F is Q into VB sin theta. Now we need to define the SI unit of magnetic field, that is B. Now we will derive an expression for B from this equation. So from this we can write B as equal to F divided by QV sin theta. QV sin theta. B is equal to F divided by QE sin theta. Now if Q equal to 1 coulomb, and V equal to velocity equal to 1 meter per second, and if the charge is moving perpendicular to the magnetic field, that is the angle between V and B is 90 degree. If theta is 90 degree, then sin theta becomes 1. Then in this equation, if you substitute everything, we get then B is equal to F. B is equal to F. So now by applying the unit, I can say that B is 1 Newton divided by 1 coulomb into 1 meter per second into sin 90, that is 1. Or this will become equal to 1. The unit is Newton second per coulomb meter, or sometimes I can write it as Newton divided by ampere meter, because S by C is ampere. The unit is Newton second per coulomb meter, or this is also known as Tesla T. Tesla, or the symbol is T. Newton second per Coulomb meter. Tesla. Thus magnetic field induction at a point is said to be 1 Tesla if a charge of 1 Coulomb moving at right angles to a magnetic field with a velocity of 1 meter per second experiences a force of 1 Newton at that point. The magnetic field induction at a point is said to be 1 Tesla. If a charge of 1 Coulomb while moving at right angles to a magnetic field with a velocity 1 meter second per second experiences a force of 1 Newton at that point. The magnetic field induction at a point is said to be 1 Tesla if a charge of 1 Coulomb while moving at right angles to the magnetic field with a velocity 1 meter per second experiences a force of 1 Newton at that point. This is how we can define the SI unit of magnetic field. Now next you take down a proton is, next question, a proton is moving along positive x-axis positive x-axis in the presence of a uniform magnetic field, positive x-axis in the presence of a uniform magnetic field along positive y-axis. What is the direction of the force acting on it? A proton is moving along positive x-axis in the presence of a uniform magnetic field along positive y-axis. What is the direction of the force acting on it? Now we know when a charged particle is moving in the presence of a magnetic field, experiences a force. Now here given proton is moving along positive x-axis. Given proton is moving along positive x-axis. Therefore, I can write the velocity of the proton v is equal to v into unit vector along positive x-axis, that is I, unit vector I, because along x-axis. Also given the magnetic field is acting along positive y-axis. The magnetic field B can be written as equal to B into J, unit vector J, because field is directed along positive y-axis. Positive y-axis. Now it is a proton, so Q is anyway equal to Q itself plus Q itself. I can take Q is equal to plus E, because it is proton. Force is given by F is the force acting on proton, F is equal to Q into V cross B. Now this is equal to E into V is V into I cross B into J, or this can be written as equal to E into V into B into I cross J, and you know I cross J is K. Therefore, force acts along plus Z direction. K we got, so therefore force acts along plus Z direction. The force is along the positive Z direction.